Good morning, everybody. We are going to discuss on the topic of operational amplifier. This is a basic block diagram of an operational amplifier which is having two input terminal. What this input terminal is commonly known as the inverting input terminal, and this terminal is known as the non-inverting input terminal. And we are giving input signal as V1 and V2 to the non-inverting and inverting terminal respectively. And therefore the differential input signal VID is V1 minus V2, and at the output of the operational amplifier we will be getting gain of the differential input signal. Here the AD is nothing but the differential gain of this differential amplifier. So the output voltage is AD times VID. There are few parameters of the differential amplifier like input current, input resistance, output resistance, differential gain, common mode rejection ratio, bandwidth, slew rate. So the value given here are for the ideal case. So if we consider that operational amplifier is ideal, then the input current should be ideally 0, the input resistance should be ideally infinite, output resistance should be ideally 0, open loop gain, differential gain should be ideally infinite, CMRR, common mode rejection ratio should be infinite, bandwidth infinite, and slew rate infinite. Now if we assume that this op-amp is an ideal op-amp. Now here we can see this is one circuit where we are giving input to the non-inverting into the inverting terminal, and we want to the main aim of this example is that we have to find out what is the output of this differential amplifier. Now if we consider the overall op-amp is ideal, this means if we consider the open loop gain of this operational amplifier is infinite, then for finite output this differential input signal should be 0. Now if as this non-inverting terminal is grounded, voltage is 0, therefore this node also should be 0. However, it is not connected to the ground, therefore this is known as the virtual ground. So here please consider that this voltage, this node voltage should be 0 for this circuit. It is not like that for all the operational amplifier this node voltage will be 0. Actually this node voltage and this node voltage, they will track each other if the feedback is negative. Now if we assume that the Rin is infinite for ideal operational amplifier, therefore the input current to the operational amplifier should be 0. Okay, so under this assumption, let us apply the common Kirchhoff's voltage law and Kirchhoff's current law equation on top of this overall amplifier circuit. If we apply the Kirchhoff's voltage law at the input side, therefore we are applying an input voltage V in here. This already you have seen is the zero potential due to virtual ground concept. So the I1, the input current of this differential amplifier, will be V1 by R1. Now if we apply the KCL law, that means the Kirchhoff's current law at this node, this is the incoming current and this is the outgoing current. As the input current of this differential amplifier should be 0, therefore this IF, the current through RF is nothing but the feedback resistance, through the current through feedback resistance should be equal to the current through input resistance. Therefore this IF should be equal to I1. Now if we apply the output side, if we apply the Kirchhoff's voltage law at the output side, this is nothing but output voltage V0, and this is nothing but our ground potential, this is nothing but virtual ground. Therefore if we apply the Kirchhoff's voltage law, the output voltage will be V0 should be minus IF times RF. So this will be minus IF times RF, and IF already is equal to I1, which is nothing but V in by R1. Therefore if we replace this IF by V in by R1, we will be getting minus V in RF by R1. So if we divide V0 by V in, we will be getting the overall gain of the amplifier. Please note that this is the overall gain of this amplifier. This is not the gain of this op-amp only. OpAmp is having a gain of infinite. Under this condition, the overall amplifier gain is minus Rf by Ri. Here you can see that the gain expression is having one negative term. This negative term represents the phase inversal of the input and output. So the output waveform will be the inverted in the phase of the input signal. Now this is another circuit where you can see we are giving input to the non-inverting terminal and taking the output signal, feedback part of the output signal, and giving it to the inverting terminal. So your task will be find out the gain of this output divided by input. So one information is there. Please note that these two terminal of the differential of these two input terminal of the OpAmp, they should try to track each other. Okay, so you have to find out the gain of this amplifier, and next you have to find out what is the phase relationship of the input and the output signal. Now one typical case I have given, what will happen if Rf is 0 and R1 is infinite? What will happen to the overall amplifier gain, and is there any usefulness of this circuit? Can you guess anything? What may be the usefulness of that circuit, of that special case? So this is particularly for your homework after listening this video, and these are some references. So if you need any more detailed discussions, you can go through these references. Thank you.